Alright, this is the practice that we did today with elimination and substitution. Let's see. So the first one, actually, I wanted you to graph it. So let's look at the graph of the first one. So the first one, y equals x plus 5. Our y-intercept is 5. And we know our slope is 1. So we're going to go up 1 and right 1. Right, that's our slope, but rise or run. I'll put a couple of these on here to make sure I can get my lines straight, because you do want it as accurate as possible when you're solving with graphing. So my second line, same thing. This time my y-intercept is -1. And then my slope is -5 over 1. So I'm going to go down 1, 2, 3, 4, 5, and then right 1. So here's the line for this one. Just make sure I get it right. Okay, that's pretty accurate. And remember, what we're looking for is where do the two lines intersect at. And it looks like they intersect approximately right here. And that is the point, -1 and 4. So that's what we're doing when we're solving these systems, is we're just trying to figure out the intersection of the two lines. Of course, the rest of it is algebraically. Let me go ahead and add my paper here. So I'm going to be working out these actually down here. Okay, so let's start with number 2. So for number 2, I would definitely use substitution. On that one, we have y equals twice. So I'm just going to take those two things that y equals, the x plus 6, and the 2x, and I'm going to set them equal to each other. Because y equals both of those, logically they have to equal each other. And then you'll just solve it. I'm actually going to subtract x from both sides. So that's going to give me 6 equals 1x. So x is 6. That's my first solution. And then I would just need to take and plug that into either one of the equations. So like if I use the bottom one, for example, the y equals 2x, right? That was the bottom equation. And now we know x is 6. So 2 times 6. So that means the value of y is 12. So there's our second solution. So in other words, if I were to have graphed this equation, or these two equations, they would intersect at the point 6 and 12. So that's number 2. Substitution, very easy on that one. Okay, number 3, probably need to break out my calculator for this one. This is the one that we're going to have to multiply both, so let me go ahead and write them both down. -6y, making sure I'm copying the problem correctly here. All right, here we go. So this is the one we're going to have to multiply twice. I'm going to choose to make the y value the same because I can actually make it a smaller number. It really doesn't matter which one. Like I could make both of those x's a 30 pretty easily. I'm going to choose to make the y as an 18 though, just because it's smaller and I can do smaller numbers in my head. So in order to make the top one an 18, I would need to multiply by 2, obviously, right? 2 times 9 is 18. I need to make sure I multiply the entire equation by 2. So 6x plus 18y equals 66. And then the second equation, multiplying that by 3. And the signs are already opposite, right? This 9 is positive and the 6 is negative, so I don't have to worry about multiplying by a negative number anywhere. So that will give me negative 30x minus 18y equals negative 42. So that whenever I get that, now I can just add the two equations together. That's going to give me negative 24x. These two are eliminated, that's 0, and that equals 24. So that just means the value of x is -1. Right, you're going to divide both sides by negative 24. And again, I don't know why that got changed. There is one of my solutions. So then I'm just going to take and, excuse me, plug that into one of the, it doesn't matter which equation you plug it into. I'm going to choose to plug it into the top equation. It just has less negatives and less chance for me to make a mistake. So 3 times -1 plus 9 equals 33. Excuse me, 9, I forgot my y. So -3 plus 9y is 33. Of course, we're going to add 3 to both sides on this one. All right, we're just solving the equation at this point. This is pretty easy. So I get 9y equals 36. And of course, if I divide by 9, I get y is 4. So the solution to this one, again, that's my y value. So So the solution to this one would be -1 and 4. So number 3, definitely would like to do elimination on that one. That would have been terrible. Okay, maybe not terrible with substitution, but also not great. All right, number 4. Number 4, I'm going to do substitution on this one. You have 3x plus 2y is 7. And y equals -3x plus 11. All right, so since we already have the y equals, I'm just going to substitute that into the second equation for my y value. So I end up with 3x plus 2 times -3x, plus 11. And of course that equals 7. Again, I just substituted that into the first equation for the y value. Again, that's the reason why we call it substitution. And obviously from here we're just going to work it out. Right now we have an equation that has
Miss Taylor, Miss Laird's bus.
only one variable. So 3x plus -6x plus 22 equals 7. So whenever I combine these two, right, these are like terms, they're on the same side of the equation, I can go ahead and add them together or subtract. In this case, that's going to give me -3x plus 22 is 7. And then I would do the opposite, right? I'm going to subtract 22 from both sides. So that's going to give me -3x is -15. And that would make x equal a +5. So that is the value of my x. Now to find the y, I totally would suggest just using the equation that already has the y equals, because that's definitely most easier. So y is -3, and we just figured out x was 5 plus 11. So you get 4 whenever you do that. So that means the solution to the equation is the point 5 and 4. All right, number 5. Number 5 is definitely easiest using elimination. Because if you look at number 5, -12x minus y equals 6, and 17x plus y equals 4, like our y's are already the same value. And they're also already opposite signs, so I don't have to do anything fancy on this one. I can just go ahead and line it up and add it in the columns. That's going to give me 5x here. Again, these two are going to add out. Those are 0. They are eliminated. And 6 plus 4 is 10, which would make x equal to 2. And then, just like before, we're just going to go and take and substitute that 2 into one of the other two. I'm going to choose to put it in this equation. Again, less negatives means less chance for me of making a mistake. So 17 times 2 plus y equals 4. 17 times 2 is 34, plus y is 4. I would have to subtract 34 from both sides. So that means that the value of y is -30. So the solution to this one would be the point 2 and -30.
Mr. Belcher?
All right, the last one of these, number 6, like I mentioned in class, number 6 honestly could go either way. Like if you like substitution, this would not be a bad one to do substitution with, because one of your variables in the first one already has a coefficient of 1. So you could take this first equation right here pretty easily and just go ahead and make it say x equals, and then use substitution. I'm going to use elimination on this one, just because I want to. Because this one's, oops, that's not 18, that's 38. Sorry. So anyway, so this one I could either make the x's both 5s, or I could make the y's both the 6. It really doesn't matter which one you want to do. I believe in class whenever I did that one, I made the y's a 6, but I actually need it to be a -6. That way whenever I add them, they equal 0. So I'm going to multiply by a -2 instead of just a +2. So this top equation is going to change into -2x minus 6y equals -26. And then the bottom equation is just going to stay. 5x plus 6y equals 38. And I can add those up. So negative 2 plus 5 is 3x. Of course, these two go away. That was the whole point of making them the same. And you get 12 on this side. So that means the value of x is 4. Now whenever I get ready to plug it in, again, it doesn't matter which one you choose. I'm just going to choose to use the top one because it just looks nice. So that's going to give me 4 plus 3y is 13. So if I subtract 4 from both sides, of course that's going to give me 3y equals 9, or y is 3. So the solution to number 6 would be the point 4 and 3. So those all 2 through 6 are just basic substitution, elimination. Use what you feel comfortable with. And then we get to the back. We come back up here to the actual problem. All right, number 7, as I mentioned in class several times, that you're always going to have two things going on. So like at number 7, we're selling 2 kinds of wraps in the school cafeteria, vegetarian and chicken. And you see here they give me the cost of the vegetarian, they give me the cost of the chicken, and then they give me the total dollar amount. They also tell me like a numerical value of like how many, like the amount. So those are going to be where my 2 equations come from. So I'm going to write the equations again down here. Go back so I have some room. All right, so it says, so I'm just going to let x be the vegetarian wraps. It's always important to define your variables. That way when you find your x and your y, you remember which one is which. And then I'm going to let y be the number of chicken wraps, which would make my first equation, x plus y equals 70, right? Because it says in the problem that they sold 70 wraps, so the number of vegetarian wraps plus the number of chicken wraps has to be a total of 70 wraps. They also give me the dollar amount for each of those. So if the vegetarian wrap costs $1, that's just going to be 1x, right? $1 times x. The chicken wraps are $1.80, so $1.80y. And the total amount that they sold for was $98.80. So those are my 2 equations that I'm going to need to solve. Again, this one would be very, very easy to use substitution or elimination on. I'm personally going to use elimination, as I have mentioned. I'm a little partial to that one. But, and my x's are almost the same, right? Like these 2 are almost the same. The only difference is like one of them needs to be negative. And it really doesn't matter which one you let be negative. I'm just going to take and multiply all the top by a -1. So here's what that's going to give me. That's going to give me negative x minus y equals -70. And then, of course, I'm going to leave the bottom the same. X plus 1.8y equals 98.8. And then I can add them up. Of course, again, the x values are going to add out. That's 0. -1 plus 1.8 would be 0.8y. And 98.8 minus 70 would be 28.8. Sorry, my bad. 28.8. And then I would need to divide by 0.8. We all know I cannot do decimals in my head, especially today. Divided by 0.8, and you get 36. So that means that 36, that's my y value that I found, so that means that's how many chicken wraps. So 36 chicken wraps were sold. And then, of course, I mean, you can think about it in a logical way or an algebraic way, however your brain decides it wants to function. We know that the total number of wraps was 70, right? So I would just need to do, like if I thought of it in an algebra way, it would be x plus 36 is 70. Or, you know, you're just going to be subtracting 70 from 36 from 70, right? It's a logical explanation. So 34 vegetarian wraps. And that's number 7. Number 8 is very similar to the one that we did last week whenever we talked about the break-even point, except for we're going to do this one algebraically and not graphically. Okay, let me go back up to the problem again for a second. here we go. So at the local ballpark, the team charges. Okay, so charges means they're going to be getting this money, right? They're going to get $5 for each ticket. Sorry, I was using my highlighter there. They're going to get $5 for each ticket, and they're going to make $1,300 in concessions. So that's the amount of money that's coming in. They also have money that needs to be going out. So the amount of money that's going out is they're going to pay their players $1,800. They're going to pay the other workers $1,500. And also they're giving each person who buys a ticket a bat, and the bat's going to cost $3 a piece. So I need to know where those two different situations meet or where they break even. So let's look at this one. Algebraically speaking, number 8. Here we go. Boop. All right, so if I wanted to look at the amount of money that's coming in, and I let X be the number of tickets, and then Y is just going to signify the dollar amount. Again, it's both cost and revenue, because I have money coming in and money going out. So I know it represents the money. So for the amount of money coming in, it's going to be Y equals $5 per ticket plus the money they're going to make from concessions. So that's the money that's coming in. Now the money that's going out, I see here that it tells me that they're going to pay the players $1,800 and $1,500. So I'm just going to go ahead and add those two together. So the money going out is going to be $3,300 plus they're paying $3 per bat. So every time they sell somebody a ticket, we're going to assume that they also get a bat. So $3 times X for my cost. So those are your two equations. So if I look at these two, I would probably definitely want to use substitution with these if I'm solving them algebraically. So since Y equals both of them, that means that these two expressions need to equal, right? And that makes sense. I want to break even. What am I doing? That is an equal sign. So I just have this equation, and then I'm just going to solve it, right? This one's not too bad. I will be subtracting 3x from both sides. So that's going to give me 2x plus 1,300 equals 3,300. Excuse me. And then subtract 1,300. So you get 2x is 2,000. And of course, if you divide both sides by 2, you get x is 1,000. So that means that in order to break even, they need to sell 1,000 tickets.